So, double angle formulas. So you got a large block right here of things that you can use, and fortunately, like you guys saw, all these will be on that cheat sheet that you can use. So it's more a matter of can you apply it than do you have to memorize it and then apply it. So hopefully that will help a little bit. Okay, so what is given to me? The cosine of theta is in -2/5. That gives me some information. This tells me that I'm in quadrant. What quadrant am I in? Quadrant 3? Yes? Past pi, but in front of 3 pi over 2. So for A, just like many of these other problems, start with drawing a picture. You are at a -2, that's the adjacent side, so that's a -2, and your hypotenuse is 5. And you are supposed to find the sine of twice this angle. Well, I know I can find this. I can find the sine, right? Yes? So out of these here, which one do you want me to use to find? Well, I don't have a choice, do I? There's only one that you can use. You need to use this one. 2 times the sine of the angle times the cosine of the angle. Well, the cosine of the angle is given, so the sine of the angle we just need to find. So we need to find what this side is over here. So x would be the square root of 5 squared, which is 25 minus 4, right? So it's the square root of 21. Are we okay with this? So it is a negative here, so it's a negative square root of 21. And that's one reason I like drawing the picture, so I don't forget about that. And so the sine is a negative square root of 21 divided by 5. And then I'm just going to fill in that little formula there, which says that the sine of 2 times theta is twice the sine of theta times the cosine of theta. So this is twice the sine of theta was a negative square root of 21 divided by 5. And the cosine of theta was a -2/5. The negatives cancel. 2 times 2 is 4. Square root of 21. 5 times 5 is 25. So the sine of 2 theta is 4 square root of 21 over 25. Notice it became positive. If you had to guess, where would you be in what quadrant? If you are in quadrant 3 for theta, where will you be if you're in 2 theta? What quadrant? Quadrant 1? It's got to be more than 180, right? Theta. So maybe it's like 190. 2 times 190 is? 380. So I'm in quadrant 1. So yeah. Could you be in quadrant 2 maybe? Think about it. At least you're positive, right? Okay, how about the cosine of 2 theta? For that one, you got a whole bunch of them that you could use, right? You could use cosine squared minus sine squared. Since we did figure out what the sine is, that would have worked. Yes? We could use 1 minus twice the sine squared, or 2 times cosine squared minus 1. So if I didn't want to do this mess here, I would have picked which one? Yeah, the bottom one, because it only relies on the cosine, and that's the only thing that's given. So I could just do this. Twice the cosine squared, which is -2/5, minus 1. So I do need to square it. That is important. So this is 2 times 4/25 minus 1. So that's 8/25 minus 25/25, which is -17/25. Does that make sense? Just to satisfy my own curiosity, let's use cosine squared minus sine squared. So what I'm doing now is using cosine squared of theta minus the sine squared of theta. And that should give me the same answer, right? I have the sine right there, so that's why I don't mind doing this one here. So what do you got here? 4 over 25 minus 25, which is over 25, which better be that way, right? So notice it did work. Okay? So that's just using it. So it's a matter of making sure that you draw a picture, find the right information, and plug it into one of the 4 formulas that's given to you. Okay? Alright. Moving on. Find a formula for the tangent of 2 theta in terms of tangent theta. Alright. Well, that one seems doable, because that's like the bell work one that we did. So the tangent of 2 theta can be written how? That's the tangent of theta plus theta. And then we have a rule for that, which says tangent theta plus, well, tangent alpha plus tangent beta. So I'm just going to fill this in as I talk. And then it's 1 minus, if that's a plus, then that should be the minus, I believe. And it's 1, and that's tangent theta times tangent theta. And when you do this, you get twice the tangent of theta over 1 minus the tangent squared of theta. So there, you could consider that a new identity, right? So tangent 2 theta is twice the tangent of theta divided by 1 minus the tangent squared of theta. Are we okay with that one? So that's just the bell work version of the tangent. Alright, the next one's a little trickier, just because of the reading part already. So let's see what they're asking me. So I need to do the sine of 3 theta, right? And I can only use sines and cosines, right? Alright. Let's see. Can I split 3 theta this way? 2 theta plus theta? And that's alpha and that's beta, right? Yes? So it'll be the sine of 2 theta and then the cosine of theta plus cosine of 2 theta and then sine of theta. Are we okay with that? So now I have some choices here that I can make, not so much for the first one, but we just saw that the sine of 2 theta is equal to what? 2 sine theta cosine theta. Alright, so let's plug that in here. So the sine of 2 theta, I'm going to replace that with 2 sine theta cosine theta times the cosine of theta plus the cosine of 2 theta, and you want me to use the cosine squared minus the sine squared? Is that where you were leaning towards? Okay, we'll use that. So that's the cosine squared minus the sine squared, right? Okay. Do we have any other choices here for the cosine? So yeah, we could have used 1 minus 2 sine squared, or 2 cosine squared minus 1, and all of those would work. Okay, so we'll just use this one here. So that's the cosine squared of theta minus the sine squared of theta times sine of theta. And then we'll just have to clean it up a little bit. So cosine times cosine is cosine squared plus cosine squared times sine, right? Let's see, I'm going to write that in a different order. I'm going to write that as sine theta cosine squared of theta. This way the sine is always mentioned first. Minus sine cubed of theta. Yes? Okay. 2 sine cosine squared plus 1 sine cosine squared is how much? 3 sine cosine squared minus sine cubed of theta, and we can leave that. we could factor out the sine, but it doesn't help much in terms of looking at it. So the sine of 3 theta is now written strictly with either sines or cosines. One way or one reason you might want to do this is, what if you have sort of a difficult problem and you do know that the angle that you're working with is like 15 degrees, right? And then now what happens if you make it 3 times as big? Do you really want to redo the whole problem, or could you use a formula like this and then just figure out what's going on based on that formula? So this is why we do rewrite stuff, so that when we're looking at a situation where we have a known angle and we know everything about that situation, we could then sort of calculate, well, what happens if I make the angle 3 times as big or twice as big? And the same kind of trick we can obviously do for like 4 or 5 or 6 as well, because a 4 would just be 2 theta and 2 theta, and then you split the 2 theta into theta and theta. So you're just splitting more and more and more. But it might prevent us from having to redo things completely if we're doing a difficult word problem or an experiment. So in case you're wondering why in the world would you ever do this, think about it from that perspective. Okay. The following can all be derived by rearranging the double angle formula. So I started on that a little bit, right? For example, this one came from cosine of 2 theta was 1 minus 2 times the sine squared of theta. Do you see how if I rewrite this, and I'll do it one more time, we'll do it a different way this time. Are we okay with this? Take away the negative, so this becomes 1 minus the cosine of 2 theta is 2 times the sine squared of theta, divide by 2. So the sine squared of theta is 1 minus the cosine of 2 theta divided by 2. Okay, this one and this one can be found similarly. That means in the same matter. Are we okay? This one I'll leave sort of for you. I will show you the tangent squared because I think it's slightly different maybe than what you're thinking. So the tangent squared would be the sine squared divided by the cosine squared, right? Yes? Okay. And we just proved over here that the sine squared was what? That one? So 1 minus the cosine of 2 theta divided by 2. And then we're going to divide by the cosine squared. And that one I sort of left up to you, but we have this one over here. So dividing by means multiplying by the reciprocal, right? So I'm going to flip that and write it as 2 over 1 plus the cosine of 2 theta. And then this is how the tangent squared of theta can be written, because these two cancel. So all you've left with is 1 minus the cosine of 2 theta divided by 1 plus the cosine of 2 theta. Okay, so that one uses the previous two. Now I know I didn't prove one of them, but I think you get the gist of that. It might be a homework problem. Hopefully it is. Okay? Okay. Write an equivalent expression for cosine to the 4th that does not involve any powers of sine or cosine greater than 1. Not sure what they're asking me there. Let me see. So cosine to the 4th of theta, and I'm supposed to write only things that look like this: sine theta or cosine theta. Are we okay with that? With the question? Well, I can break the cosine to the 4th up this way, right? Cosine squared. Okay? And the cosine squared can be written how? From the one that we just did. Cosine squared is 1 plus the cosine of 2 theta. Yes? Divided by 2, I believe. Yes? and then square that. Okay? We're good with that? That doesn't quite get me there yet, because this will be a cosine squared, so I'm going to actually multiply this by itself. So that's 1 plus the cosine of 2 theta divided by 2 times itself. Let's see. Let's get rid of this. So that's 1 plus the cosine of 2 theta times 1 plus the cosine of 2 theta, right? I'm trying to see how I can say this so that it makes sense to you, hopefully from a pattern. So what's 1 plus x times 1 plus x? That's really what I'm asking you here in the top. So I believe that gives you 1, right? 1 times 1 is 1. Then you get 1x plus 1x, that's 2x, right? So 2 cosine of 2 theta. Are we okay with that? Plus, and then the last term should just be x squared, right? That's the cosine squared of 2 theta. Are we okay with that? Okay. And then the 2 over 2 just becomes a 4. Are we still okay with that? Okay. So I'm going to write this slightly different then. So that's 1/4 times the cosine squared of 2 theta plus 2 cosine of 2 theta plus 1. Are we okay with that? And here we got a leap. I'm trying to see how I can explain that better. And I think I'm going to get stuck on that for a moment. So the cosine squared of 2 theta can be written this way. That's 1 plus the cosine of 2 times 2 theta divided by 2. Are you guys okay with that? Let me see if I can explain that a little bit better. The cosine squared of theta is what? That's 1 plus the cosine of 2 theta divided by 2. Is that right? Yes? So if I make this 2 theta, then this should be 2 times 2 theta, shouldn't it? Well, that's what I just did over here. I just replaced this cosine squared of 2 theta with a 1 plus the cosine 2 thetas. So that's actually going to be 4 theta. Hopefully you can sort of see that. And then the other one I'm okay with already, because 2 times the cosine of 2 theta, I'm okay, because I could only have sines and cosines of thetas, sort of, or multiples of those, plus 1. So ultimately you get this expression. You get 1 over 4 times 1 plus the cosine of 4 theta. So I don't have a power, so I'm okay with this. I'm sort of trying to follow the rules that they gave me, plus 2 cosine of 2 theta plus 1. Okay, clearly that's a challenging problem. I don't think I have too many of those, but I wanted you to see this little trick over here. Mostly this trick. That if that was 2 theta, then this just becomes 2 times 2 theta. Hopefully that makes sense. Okay? Yes? No? Can I move on? Yeah, I can clean this up. You mean this 2? This 2 over here? Yes. Yeah. I mean, if theta was 50, then this would be 100, right? 2 theta would be 100. Well, if I make that 100, then this would become 2 times 100 is 200. So sort of this, that's the idea there. That the multiple here really doesn't matter. But if you make this a 2 theta, just make that a 2 times 2 theta or a 4 theta. Okay. Last problem. Sorry, I know this is long. So we have an angle, initial velocity, the range that would be the horizontal distance, is given by this formula over here. and we're supposed to show that these two things are equal. Notice the big difference here. Are you guys okay with that difference? Okay, and we just found out in the bell work that the sine of 2 theta could be written as 2 times the sine of theta times the cosine of theta from way in the beginning. Okay, so sine theta cosine, so I could just divide here by 2. So if I divide here by 2, I have an expression for sine theta cosine theta. Does that make sense? So I can write this as 1 over 16 times the initial velocity squared, and then I'm going to, instead of writing sine theta cosine theta, I'm going to write sine of 2 theta divided by 2. And then this 2 just slides all the way over here to make this a 1 over 32. That's the other change that I didn't really point out, so we didn't quite need it yet. So these two equations are equivalent. And then maybe now you can see why you might want to rewrite some things, because the initial formula here required me to both have a sine and a cosine. Okay, now this function's only depending on a sine, and that's usually easy to work with. It's one variable less. That would be nice. Okay? I got one thing left. I got to do B as well. Okay, so then the question in B is find the angle for which R is a maximum. Well, that hinges on this thing. R is maximum. R is the largest value possible for R. The 1 over 16 is fixed. Well, it actually became 1 over 32. The initial velocity is fixed, right? Okay. And, well, I mean, once the cannon shoots, it's fixed. So the only thing that determines the maximum is the sine of 2 theta. So what is the maximum number that the sine of 2 theta can attain? The largest number for the sine of 2 theta that you can ever have is what? Is 1, right? So the sine of 2 theta would be 1. That happens when 2 theta equals not 2. When is the sine of an angle equal to 1? That would be here, not at 0. This is 0, 1. Sorry, this is 1, 0. Right? The sine is 0 here. Here the sine is worth 1. What angle do I have for that? 90. So 2 theta has to equal 90 degrees. So the largest horizontal distance will be attained when you shoot at what angle? Not the other way. 2 theta is 90, so theta will be 45. Okay. If you were a king or a queen and you were defending your castle, that would be important to know, because this is the angle you will want to shoot your cannon at when you're trying to kill somebody. Put it bluntly, right? Okay, you would want to shoot it at 45 degrees. It's really the same thing when you throw objects, usually, and that kind of stuff. So, but that's where the 45 comes from.